Hi and welcome back to the channel. I'm Adam Morton, CTO at Intelligent Group, and we're continuing on our exploration of Snowflake Cortex, including all of the capabilities that make up this new groundbreaking service from Snowflake. In this episode, we're continuing our journey, specifically looking at the ML models. We've already looked at the anomaly detection and time-based forecasting models. This time though, we're looking at the classification model, and this helps our customers look at everything from predicting customer churn rates to detecting fraud. And so classification models really help you and your business provide invaluable insights that help drive strategic decisions within your business. In this video, we're going to look at what classification is, why it's useful, and the steps involved in using it in Snowflake before we actually head into Snowflake and look at a real world demo. So what is classification? Well, it's a type of machine learning model or algorithm that sorts data into predefined categories or classes. And it does this by analyzing patterns in historical data, also called training data, so it can predict the category of new unseen data. Now, classification models can either be binary, so it predicts two different categories, true or false, for example, or it can be multi-class, and that means it's predicting more than just two classes. And we're going to see both of those flavors in our demonstration at the end of this video. Common examples of this can be determining emails which are spam or non-spam, for example. And so why is classification useful? Well, it's used across a wide range of industries to enhance decision-making processes, and a few common use cases are customer churn prediction. So identifying which of your subscribers, for example, are likely to leave a service before they actually do. Knowing this is really valuable to our customers because then they can take a proactive, corrective approach, just focusing on those customers with a high propensity to churn, therefore targeting their resources very effectively. The other one is credit card fraud detection. So looking at transactions and flagging those if they are fraudulent versus legitimate. This helps protect our customers as well as reducing financial loss. So this really helps our clients improve customer retention rates, improve and enhance their security, and streamline their operations. How do you actually do this with Snowflake Cortex? Well, in previous videos now we've touched on how Snowflake make this much more easier than ever before, and that comes with a range of benefits. It's got the security model wrapped around it, it's got a level of governance applied to it. You don't now need to move those data assets outside of your Snowflake environment into a dedicated AI or ML tool to do some of this functionality with your data and produce these insights that we're talking about. You can do it in place, almost bringing the ML models to where your data lives in Snowflake. And that's one of the big benefits. Using a few lines of SQL, as we'll see in the next step in the demo, it makes it really accessible for people with a non-statistical maths background, or those of you who come from a traditional data science background, to take advantage of these things. So how do you do it? Well, first of all, you need to create a classification model. And to do this, you're going to need some training data. So you start by preparing your historical data, and that needs to include a target column that indicates those categories or class labels that you want to predict in the future. Using this historical data, you can then create and train your model, your classification model in Snowflake. It's trained on this historical data because it learns to recognize the patterns associated with each category. Once you have your model in, you can look to classify new data, unseen data. So your model is trained, it understands what to look for, it understands the association of different data points to particular categories and how that drives those categories outcomes. So if you're looking for a way of classifying new customers as likely to churn or not based upon their behavior patterns, that's a great use case to apply to classification. So without further ado, let's jump into Snowflake and take a look at a real world demo of how you can use this in your own environment. Okay, so here we are in Snowflake, and the first thing we're going to do is just set up our environment by creating a database. Next up, we have a lot of synthetic data functions, which I'll show you in a moment, to create our data that we're going to use for our classification examples. It's going to create a table called training purchase data. This is going to have two feature columns, a binary label column and a multi-class label column, which we'll see in a second, and a second table called prediction purchase data. And this has 2 feature columns. Don't forget, you can grab the sequel off the Snowflake documentation website under classification, which is in the ML functions section. Firstly, let me just quickly, as a little bonus, talk you through these synthetic data functions. So uniform, first of all, takes 3 different input values, a minimum and a maximum number that you would like the uniform function to return numbers within this range. Then it needs an expression here that serves as a raw source of uniform random numbers. And typically what you'll see here is the random function. And as it suggests, a random function returns a random number. Finally, then we've got the generator table function. And within the generator function, you can create a number of specified rows. In this case, we're looking for 100 records, and this basically extrapolates out this select statement where we've got these functions in there 100 times to create a table. So that's enough of that. Let's create these tables. We can take a look at what they look like. Train and purchase data. We've got a user interest score, a user rating, a label, and then a different class in here, such as add to wish list and not interested. We'll come back to that a little later. And now we've got our prediction purchase data. Here's our 2 columns. We've got a user interest score and a user rating. First up, we want to train our binary classification model. And to do that, we're going to create a view. So similar to last time's demo, we're going to create a view to set up the data. So we've got this view, binary classification view. We're pulling out the user interest score, the user rating, and label from our train and purchase data. And we're going to use this to train our model next. So here's our create or replace classification model. And we've called it model underscore binary. We pass in our view that we've just created and we tell it what target column we're looking to predict. We'll run that and that creates and trains the binary classification model for us. Now, after we've done that, we're using this predict method as part of the model itself to provide the labels for the unlabeled purchase data. So here we can see we're using the predict function. We're using the object construct function to create key value pairs of features for the input data. And earliest in that column is prediction. And we're looking at our prediction purchase data. So our second table that we created, here's the stuff that we want to have a prediction against, based upon our historical data that we've trained our model against. So here we go, it comes back to us in this format. If I click on one of these records, we get a better formatted view of it here, where it gives us the probability of this particular record being true or false. Now, if you want to join these predictions to the features, we can use a query such as this. So again, we've got our predict input data and object construct again. We're just bringing in the other columns from prediction purchase data alongside our key value pairs. Here we go, where we've got our user interest score and our user rating. We're using these 2 as inputs to generate our prediction. And so that's our binary model. Effectively, we're predicting if it's true or false, one or the other based upon our inputs, in this case, user interest score and user rating. Now, how about if we wanted to use a multi-class identifier? So this is where we can have multiple outputs. So let's set up our data for this. So we're going to create our view, multi-class classification view, pulling out the user interest score, the user rating, and the class from the train and purchase data. So we've created the view. Let's take a look at the top 10 records from here. Now we've got these classes, and these classes here are groupings, our add to wish list, our purchase, or not interested. And so we want to build a model that's going to predict which category, based upon our user interest score and user rating, we predict that our records would fall into. So we're going to create our classification model. We're going to call it model underscore multiclass. Again, we're going to pass it in the view that we've just created this time, the one that we're looking at right here. But this time we're predicting the class as the target column name. Not only now are we looking at a binary, true or false, we're looking at multi-classes and multiple classifications these records could fall into and their predictions around it. So right now we're building and training this model on our data, which is coming from this multi-classification view. That's now built. Again, we can use the predict function to do this and with the object construct as before. However, to make it useful, we probably want to save these into a table for further analysis. And the easy way to do that is create a replace table, give it a name. So we're using the create table as syntax, pulling out all of the columns along with our predictions in our key value pairs from the prediction purchase data that we're providing it with. So let's take a look at what this looks like after we create the table. So now we've created the table, we're using this particular query here to allow us to pull out this particular key value pairs that we want and round up the predictions to 4 decimal places just to make it more readable. We'll look at the top 5 records. All of it's being predicted as in the not interested class, and you can see the probability here is the highest, which is why it's coming up as not interested, a much lower probability for purchase class and add to a wish list. If we just look at all of our records and not just the top 5, we can see here we've got other predicted classes such as add to wish list and purchase. So that is how you can pull out those records from this My Predictions table that we've created based upon classification models. We've looked at a binary model, how to build and train that and then provide new data against it, as well as multi-class model. I hope you found that useful. If you did, keep watching, keep subscribing.